Hello, welcome everyone. Happy Tuesday. I hope you're all feeling wonderful and refreshed after some holiday time away. Thank you for taking the time today and joining us for Apache Airflow Best Practices DAG Writing, presented by Data Engineering Digest and sponsored by Astronomer. I'm Tara, the webinar manager of Data Engineering Digest, and I am so excited to bring you this brand new session with such well-earned insights into many Airflow best practices and advanced features that can help you make your pipelines more manageable, adaptive, and robust. I am really looking forward to hearing from Tamara Fingerlin today, what I'm sure is going to be a valuable presentation. And just so you know, we will be recording this webinar in case you have to leave early, and we'll be sending it to you by email within 48 hours. You can also visit the webinar's registration page after today's session where you signed up to view the recording there as well. And we're going to send that link in the chat box right now for you. Up next, before we go any further, I want to thank Astronomer for sponsoring this webinar and helping us to make all of this happen. Astronomer empowers data teams to bring mission-critical software, analytics, and AI to life and is the company behind Astro, the industry-leading data orchestration and observability platform powered by Apache Airflow. Astro accelerates building reliable data products that unlock insights, unleash AI value, and powers data-driven applications. Trusted by more than 700 of the world's leading enterprises, Astronomer lets businesses do more with their data. And you can learn more by visiting astronomer.io. So thank you again to Astronomer. Up next, let's quickly go ahead and get some technical things out of the way. Please don't hesitate to ask questions during today's event. You can do so by submitting your questions into the Q&A panel found in the toolbar at the bottom of this window. And we'll have a dedicated Q&A session near the end of the hour so we can learn even more from our panelists. And the chat is also open for discussion and comments. Don't forget to change the blue button in the chat box to everyone to join the conversation. My wonderful colleague, Tori, will be fielding your questions and comments today, and she'll be happy to answer anything technical you might have as well. So feel free to pull up the chat or the Q&A and get familiar. Let us know where you're joining from today. Also, closed captioning is available for this webinar, and to enable this feature, you can select the Show Captions option in the toolbar. And lastly, if you have any audio issues during today's presentation, you may choose to dial in by phone. All dial-in information can be found in your webinar confirmation email from Zoom, and Tori can also relay it to you in the chat at any point if you need it. Up next, again, today I am very excited to hear from Tamara Fingerlin. She's a developer advocate at Astronomer, focusing on helping users from beginner to advanced to write Apache Airflow DAGs for all use cases. Having entered the field of data engineering after completing a data science bootcamp, she's passionate about helping others with non-traditional backgrounds get started in the world of data with Airflow. So with that, I'm going to pass things over to you, Tamara.
Thank you so much, Tara, and thanks to everyone who's joining. Thanks to everyone in the chat. Can see where you're all from. A lot of people from the US, someone from Canada. Yeah, shout out to the person from Costa Rica. Yeah, no, that's awesome. Keep those coming. I love seeing how people are interested in Airflow from all sorts of different countries and how we come together across different time zones for events like that. So with that being said, welcome. I'm super excited to talk to you today about Airflow DAG writing and some of the important best practices that you should follow when you write your Airflow DAGs. We're actually going to start with a poll. So you should see a poll on your screen now that asks you about your Airflow experience. This is mainly for me to know a little bit more about you as the audience and what to spend more time on in this presentation. But I think no matter if you're a beginner, if this is your first contact with Airflow, or if you're a more advanced user, there should be something in the next hour or in the materials that we will be sending out to you for you that is useful. All right. While you are answering the poll question, let me quickly go through the agenda. First, I will cover how to write an Airflow DAG for any workflow. So this will be a little crash course, especially for those of you who are new to the tool. And after that, you'll know how to turn your existing Python scripts into a simple Airflow DAG. Next, I will cover some of the core DAG writing best practices. So these are best practices you need to keep in mind whenever you are writing DAGs, and some of the basic Airflow features that we recommend you use in every or most of your DAGs. That's kind of the first half of the day. And in the second half of the webinar, I'm going to talk about more advanced features. So I will cover a feature you may have heard about that's called dynamic task mapping. And with that feature, you can write DAGs that adapt to your data at runtime. And I will also talk about advanced data-driven scheduling, which is a newer feature inside of Airflow that uses the Airflow datasets feature. And as Tara already said, we will have some time for Q&A in the end, but please put your questions in the chat or in the Q&A feature as soon as they pop into your head. All right, so the poll has ended and we should all see the results. So I can see quite a few people with experience in Airflow that are running Airflow in production. Also, some people who don't have any experience at all. So that is awesome. We have a good mix of people, so we can all learn from each other. And there should be something for each one of you in the presentation. If at any point you're thinking, oh, I want to learn more about this specific feature, there will be more information and there will be example code for every feature that I show in the ebook that we will share at the end of the talk, and a GitHub repository that is open source where there's full DAG code for you to run to experiment with these features. Because I think the best way to really cement your learning around Airflow features is by just testing. What does it do if I change something? It's also the most fun way. All right, so for those of you who haven't used Airflow before, what is Airflow? Airflow is the current open source standard for orchestrating your workflows and your data pipelines in code. So if you're working with data in whatever capacity, you usually have a lot of different tools. These are just very few tools, logos of different data tools that you might be using, and you have all sorts of actions that are happening in these tools. And you need to make sure that these actions happen at the right moment and with the right dependencies. For example, let's say you're a machine learning engineer, you need to make sure your training dataset is ready before you train your model. Otherwise, you will not be able to train your model. So you have a lot of complexity here potentially, and you almost need something in the middle that can act on all of these tools. And this is where Airflow comes in. So the way that I imagine Airflow is as a little octopus sitting in the middle of your data stack and making sure that all of the other data tools do exactly what you want at exactly the right time. Now, this is the crash course. So this is where every one of you who hasn't used Airflow before, also the people who maybe have used Airflow, but it's been a while, should pay a lot of attention. In Airflow, you define your pipelines as DAGs. DAG stands for Directed Acyclic Graph. So you have a graph representation of your pipeline, which always goes into one direction, and you have no circles. Those are the only requirements. So while I'm showing a very simple DAG here, DAGs can get as complicated as you need them to be, as long as you don't make any circles. On the left-hand side, you can see a screenshot of the Airflow UI. So Airflow has a UI component that shows you this graphical representation of your pipelines. And in this example, we have a very simple DAG that has two tasks. So we have a graph with two nodes. Each node is a task, and they happen sequentially. By default, you read them from left to right. So you have get cat fact, which needs to happen before you print the cat fact. Makes sense. The edge in between them shows the dependency. Now, on the right-hand side, you can see all of the code that went into creating this specific DAG graph. So you can already tell you don't actually need to write that much code or need to know that much code. And here you can see three things. First, we need to tell Airflow, hey, I'm writing a DAG. And the way I'm doing this here is by putting the @DAG decorator on top of a regular Python function, which is called inCatFact. And I'm giving this DAG decorator a few different parameters. I'm giving it a start date, so I'm telling it do not run before this date. I'm giving it a schedule, so this DAG should run every day at midnight, very simple schedule. I'm also telling it not to catch up on all of the runs that would have happened since November if I turn this DAG on today. I just want to start with the latest. And I add a tag, so I find this DAG more easily in the Airflow UI. If you've used Airflow in the past, or even if you're using it now, you might be familiar with a different syntax that uses with and then DAG all capitalized. That other syntax is also a completely valid way to define your DAGs. This is just a more modern Pythonic way. Next, I have to add some tasks. In this case, we have two tasks. The first one is defined by using a decorator. So again, I have a regular Python function on line 16, get catfact. This is just a very simple one. I'm just posting a GET request to a URL and I'm returning part of the payload. But this function could be as complex as you need it to be. You could put your whole hundreds of lines script into this task if you want to. And the only thing you need to do to tell Airflow, hey, turn this into one of those nodes into an Airflow task, is to put add task on top of the function and to make sure to call the function, as I've done on line 20. And that's already the moment where you know everything that you need to turn your existing Python scripts into Airflow DAGs. But of course, there's more to it. So in a lot of cases, you maybe want to do something that has been done before. For example, maybe you want to run a bash statement. So in this case, I don't have to rewrite everything from scratch. I could define the Python code that runs a bash command, but in this case, I'm using a pre-existing operator class. I'm using the bash operator, and this is just a Python class that contains all of the logic already to run a bash command. So I just have to give it a name, print catfact, and give it the bash command. In this case, just echo out whatever the previous task returns. Of course, this is just a simple operator. There's a lot of different operators that interact with all sorts of other toolings and make it a lot easier for you to write your pipelines, so you don't have to recreate things from scratch every time. Lastly, in this DAG on line 27, I set the dependency. So I'm saying I need to get the catfact before I print it. Makes sense. I'm using the chain function here. It's also very valid to use bit shift operators in between your tasks to say this one has to happen before the other. Chain is just, again, a more modern, a more Pythonic way of defining it. On line 30, you can see that I'm calling the function, the DAG function that I defined on line 14. This is very important. If you forget that, your DAG will not show up. All right, so I said earlier, now you know everything you need to turn your Python script into a DAG. Well, why then should you stay for the rest of this webinar? Well, there are a lot of best practices, and the reason why you should care about them is because we want to prevent this image. Apologies to the Airflow users, or like heavy Airflow users. This might actually give you an emotional reaction seeing something like that, especially Monday morning. These are all failed DAGs, failed pipelines. We want to avoid that, and we want to avoid the scramble in trying to fix this. And by following best practices, you can sometimes prevent failures, so preventing red squares and circles. And obviously, we work with data. Data is very fluid, it keeps changing. Sometimes you can't prevent a task or a DAG from failing, but at least if you follow best practices, it will be easier to troubleshoot, and you will see why in a second. All right, so let's dive into best practices. There are 3 core principles for Airflow tasks. And those are that the tasks should be atomic, idempotent, and modular. What does that mean? First, let's look at atomic. Atomic means that each individual task should just have one single responsibility. So you should have as little code and as little work in an individual task as possible. This is the example of what not to do. This is valid code, it runs, but everything is just in one giant task. And you might be asking, well, what's the problem? If it runs, it runs. I don't care how many tasks it is. And that is somewhat true until it fails. Because if the task fails, now you don't know which part of your script failed, and you have to go into the logs, and then you will eventually figure out what part failed. But in that case, if you want to recover, you want to rerun this task. So in Airflow, you click a blue button that says clear, and then the task will rerun. You do that manually, and it's something that's very common for data engineers to do. In this case, you have to rerun everything. And this can be really frustrating if it's a task that takes 2 hours to run, or if only the very last part of it failed, and maybe the first part contains computation that is very costly. So this is very much not ideal. What is better is taking the same code and writing it into separate tasks. So in this case, I'm having 3 tasks to do the same thing. And what I end up with in my Airflow UI is this much more observable DAG graph. And now you can imagine if the last task fails in this sequence, I can just rerun that last task and I don't have to rerun everything upstream. All right. It also means if you have atomic tasks like this here, that you can have those Airflow features that I'm going to talk about later in the presentation on individual parts of your code and not on the whole code. So maybe whenever you fetch customer feedback, you want to have a special notification. In this case, you can do that. The next best practice is to make your tasks idempotent. What does that mean? Idempotency is just a fancy way of saying the same input should result in the same output. And in Airflow, you should have idempotent DAGs and idempotent tasks if that's possible. It is not always possible. The prime example these days is if you run an inference call with a task, so you talk to a large language model, then what you get back will not be deterministic. So you can get back a different result. You all know that if you ask ChatGPT twice, you will get 2 different results. Different result for the same input. So that's an example for something that's not idempotent. But ideally, if you work with data, you want idempotency. And the reason is, for example, if you work with the sales team and you have a DAG that runs every day and fetches the latest sales data. After a week of that running, the sales team comes to you and they say, hey, we changed our logic. Can you just rerun everything for the last week? This doesn't really work if you're not being idempotent. For example, if you use the code in the left-hand side screenshot here, and if you use, for example, the date of today in your SQL statement or in how you fetch that data, and if you do that by using the datetime package, this will work if the DAG runs on its actual day. It will just use the system time it will use today. But if I rerun that same DAG run in a week, it will use the date in a week and not the date that it would use today. So you get a different output and it's not idempotent. One way that you can improve on that is by tying anything that depends on time to the DAG context. So if you're using the syntax with the add task decorated tasks, you can add the context as a keyword argument, and then you can just take different elements of the context. And one of the things that it, for example, contains is the logical date, which is the date that is attached to the specific DAG run. And if I define the task like this, if I rerun this task in a week, in a month, or even in a year, it will give me the same today and the same output. I don't really have time to dive that deeply into context today, but we have a full guide on our Learn page. So if this is something that interests you, you can say that in the chat, and Tara and Tori can link you to our Learn page where we have all of our guides. The last best practice for Airflow tasks that I already hinted at a little bit is to make them modular. So when you're writing your Airflow DAGs, you are writing software. And this is really the mindset that you should be in. If you're writing software, you want your code to be clean, documented, commented, and you do not want to repeat yourself. So you should reuse your tasks, reuse your functions, reuse variables. And if there is an existing operator, I earlier showed you the bash operator, but there are many, many more. then you should use those. And these operators are usually grouped by the tool that they're interacting with. So for example, all of the operators that interact with Azure services are part of the Microsoft Azure provider. And you can install these providers in your Airflow environment. And if you need to know whether a provider exists for the tool that you're using and which operators are in that and what the parameters are for these operators, there's a public list at registry.astronomer.io. So that's one page that I recommend you favorite, and then you can find operators for use cases, and you do not have to reinvent the wheel and write the code yourself. And the great advantage is also that these operators are tested by the open source community, so you don't have to write your own tests, and they will be updated if anything changes, for example, in the tools API. Okay, so those were 3 principles for your tasks, but I haven't actually talked about the worst mistake that you can make. And if you want to put in the chat, I'm actually curious, what do you think is the worst DAG writing mistake that you can make that will still parse? So obviously, if you forget a semicolon or if you forget parentheses, then your DAG file will just not parse if the Python syntax is wrong. But there's actually a mistake. Oh, that's a good one. Shout out to Jason for saying credentials in code. Yes, that is a big mistake. I think that's a general coding mistake. Errors failing silently, that's a very good one. That's one we will address in the features in the next section. You do not want to have an error that doesn't fail. Incorrect dependencies, yes. Suddenly you try to train your model on data that doesn't exist. Those are all really good ones. There's one though that can cost you a lot of money, potentially. Yes, that's the one, Jason. Top-level DAG code that makes external calls. And this is a dangerous one because this DAG will still parse. So it will still show up in the UI and it will start running, but you might cost your company something. Because what you can see here is you have a lot of code here that is not in a task. And especially these 2 lines are dangerous. Because what happens on line 10 and 11 is I'm making a connection to a Postgres database and I'm querying that database. Which, okay, that's fine. The problem is Airflow parses your DAG files every 30 seconds by default. So if you have that DAG in your Airflow environment, even if the DAG only runs once a month, this query will run once every 30 seconds. And now you know why this occasionally ends up costing someone quite a bit of money. If that query is costly, I hope the grocery list is not that long that it would end up being costly, but if you do this in a corporate use case, you might get an email from your database administrator. What exactly are you doing here? So this is a dangerous one. And what is important here is if you have code that either runs for a long time or costs something, like these external calls, then you need to put them into a task. So this is the exact same code, but in this case, I put them into this task to make sure that they only run when the DAG runs. In this case, the DAG runs every day, so we only make that connection and query the database once a day. There's one question I usually get on this, which is, well, what if I just want to create 10 tasks and I do that with a for loop? I don't want to write out each individual task. That is completely fine. For example, if you have a for loop and it's a static one, range 10, and then you create 10 of the same tasks, that is fine. But you need to just keep in mind, if it takes very long to generate your DAG structure, you may need to adjust your scaling parameters of your Airflow environment so it doesn't time out while fetching your DAGs. All right, so those were the core best practices. Let's talk about some basic features, and some of them address the other worst mistakes that people suggested. So there are 4 features I want to talk to you about: retries, execution timeouts, callbacks, and different DAG parameters that you may not have heard of. So the first one is retries. And with retries, what you're doing is you're basically giving your tasks more chances. So what you want to do is, if a task fails for whatever reason, it gets another chance. And this is especially important if you're dealing with brittle pipelines that come up against rate limits, against API failures. Personally, I once wrote a machine learning pipeline and it failed. I forgot about the retries. It failed because of 400 milliseconds. That was how close I was to being allowed to query the model again. Close enough, a retry would have saved the pipeline. So that's why retries are really important. And you can set them at the configuration level. If you set these configuration environment variables, you can set them for your whole Airflow instance. You can say, by default, every task gets 3 tries, for example. You can also set the retry delay, so how long a task has to wait before it tries again. And you can override this at the DAG level. So at the DAG level, one of those DAG parameters, earlier I showed you start date, schedule, catch up, and tags. You can also add default underscore args to that list. And then you can add a dictionary with default arguments that will be applied to each task in your DAG. So you don't have to add the retries to every single task. You can just say, okay, for this DAG, every task gets 3 tries, and it has to wait 5 minutes between its tries, but it has to wait longer every time that it fails. That's what retry exponential backoff means. You can also overwrite these defaults at the task level. If, for example, you have a task where you know if this one fails, it needs help, you can set its retries to 0. Something similar, execution timeouts. Airflow tasks should not run on for eternity, and you can actually tell your tasks, hey, if you've tried for 5 hours, you should just fail. And again, you can do that at the configuration level, just for all tasks in your instance. You can do it at the DAG level in the default args arguments, or you can override it at the individual task level. Now, earlier, Taj or Tai, I hope I can pronounce that correctly. You suggested that arrows failing silently is a very, very bad mistake, and I totally agree. What you want to do is you want to get alerted if something fails. And in Airflow, you can actually be alerted. Yes, got it right the first time. So in Airflow, you can actually be alerted in different cases. So not only on failure, you can also be alerted if a task or a DAG is successful, if you want that. One of the most common thing to do is up here on line 34 and line 35, I set alerts for the whole DAG. So I'm saying if this DAG completes successfully, that's on success callback, I want to execute all of the functions that are provided in this list. In this case, I'm giving it a regular Python function, which I called my callback function, and I'm also giving it a notifier. I don't have time to go into notifier in more depth in this talk, but it's basically just a way you can standardize your callbacks as a specified Airflow class. On line 35, I'm doing exactly what I'm doing with all of my DAGs. If they fail, I want to know. So on failure, I want my callback function to run as well. And this function could contain any code. At Astronomer, what we do is we have a Slack channel where failures get posted. The other thing that you can do is sometimes you care about individual tasks failing or succeeding, and then you can use the same parameter at the task level. So what I'm doing here is I put it in the default arguments, and this means each task in this DAG that succeeds and fails will also execute this function. And what you can see here is there's also plenty of other parameters. So for example, you can also tell it to execute a function whenever a task has to retry. And you can find this exact code in the example repository that is sent out to you. Last one of the basic features, the DAG parameters. So the one I already mentioned, but I mention it again because it's almost a rite of passage to forget about this one. It's called catch up. By default, your DAGs will catch up on the runs that they have missed in between the start date and the moment that you turn on the DAG. So with this DAG, start date is the 1st of November. I turn it on today. if I have catch up to true, or if I forgot about the parameter, then it will just do all of its runs that it would have done since then, which is quite a few, like at least 40. And usually you do not want to do that. So the best practice here is to set catch up to false unless you specifically want catch up behavior. And yes, almost everyone who begins working with Airflow forgets about this, turns on a DAG, and then suddenly you have a lot of DAG runs scheduled. The next one that is also in the screenshot is one that is lesser known because it was only added in Airflow 2.9, so quite recently. It's a bit long, but it tells you exactly what it does. It's called max consecutive failed DAG runs. And this means if this DAG has failed twice in a row, it will just pause itself. Like in the UI, the toggle will set itself to pause. And then it will not run again until you manually intervene. So until you clear, make sure that you have a successful run and then turn it back on. This is something that I've started to do with all of my DAGs because most times when a DAG starts failing several times in a row, you know you need to do something with it. A similar parameter that is lesser known is called fail stop. Sometimes you have tasks in a DAG that work on similar data, and you already know if one fails, all of the other ones that might still be running have no chance. So what you really want is that any failure in this DAG causes all tasks that are already running to fail, and the ones that aren't running yet will just be skipped. And you can do this very simple by just adding fail stop to your DAG parameters and setting it to true. And then you have exactly that parameter. As soon as any task in your DAG fails, the whole DAG has failed. One side note, if you use trigger rules in your DAG that aren't the default, then you cannot use fail stop. Fail stop only works with the all success trigger rule, which is the default. The next one I also already hinted at. I love to make my DAGs better documented so others understand what I meant and I understand what I was doing a week from now. So you can add tags to your DAG and you can also add a full doc string that makes it easier to describe your DAGs and make sure that everyone knows what a specific DAG does. The last one here is a feature that can be quite extensive if you want to use it. You have a params DAG parameter. And this parameter allows you to define defaults for different params in your DAG and then create forms for your users to fill out on manual runs. So the way this works is that you have a DAG and by default, for example, it fetches the information for the sales department. But sometimes your end users who may not be technical want to run this workflow and just get the information for the marketing department. And what you can do with params is you can have a drop-down menu for people to select which department they want this DAG to run on. And whatever they select will be passed into the DAG as a string and you can access that information inside any of your Airflow tasks. I don't have time to go into this in depth. This would be a 2-hour webinar on itself. But on our Learn page, we have a full guide with example code for different types of params. All right, that was already a lot. Those were all of the basic DAG writing best practices. So let's do a recap. First of all, your tasks should be atomic. Each task has one job. They should be idempotent, not always possible, but ideally, which means the same input leads to the same output. You should write your DAGs in a modular fashion. You should avoid repetition and use provider packages. And importantly, you should avoid top-level DAG code. Now, the best practice features that we covered are retries, execution timeouts, callbacks, and a set of DAG parameters. And I think I saw one question in the chat from Raj. Yes, you can add the callback function just for an individual task. Just put it with the other parameters. And if you're using the decorator, you can just put it inside of the decorator. So you have add task, parentheses, and then you have on failure callback equals, and then your list of functions. If you use a traditional operator, it just goes with the other parameters. All right, so now we're going to the second part. Before that, we have a second poll that is live for you now. All right. So the second poll is about problems that you run into usually once you start running your DAGs in production. And these best practices of the second part are also more advanced best practices that people start to think about once they write Airflow DAGs that run for a long time and that run in a production environment and in bigger teams. So the two features that I want to talk to you about today is dynamic task mapping, one of my personal favorites, and Airflow datasets. So first we will talk about dynamic task mapping. What is dynamic task mapping? Sometimes you don't know yet how many tasks you need in advance. So for example, let's say I'm writing a pipeline to generate a weather report. And I have a set of coordinates, the set of coordinates where I live here in Switzerland. And then I have a second task, and that task makes an API call to a public API that fetches the weather report for the next 7 days. Great. I have a DAG, I run it. Maybe it's so successful that my friend in the US says, well, can you run that same DAG for Seattle, please? And I'm like, okay, yeah, I'm just adding another task, and now I'm fetching it for Switzerland and Seattle every day. But what if that grows? And suddenly I have a group of friends, and every day a different number of friends wants their weather report. And I never know how many friends want that in advance and which sets of coordinates. I definitely do not want to change my DAG code every day. So now I need to start writing a DAG that can adapt to the data at runtime. And this is where dynamic task comes in. So what I'm doing now is I say, okay, I'm getting all of my sets of coordinates in a list. And then I have a downstream task, I called it extract here. And I just want to have that task running in parallel for each of the sets of coordinates that I'm getting. So in this case, I got 3 sets, and that's why there's the little 3 in the parentheses here, because in this case, 3 copies of that task ran in parallel. So this is something that you can do to proof your DAGs against data changes. This is highly scalable. The default limit is 1024, but you can expand on that limit in your configuration settings. But you could really have a DAG that runs a whole pipeline for one set of coordinates on one day, and for 1000 on the next day, and then for 0 maybe on another day. And the cool thing is it's also observable, because if you go back in time and look at your DAG history, you can just click into each individual mapped task and get the logs of each task. I will show a screenshot of that in a couple of slides. The thing that I want you to remember here is whenever you're thinking, I really kind of need one task per X, that's when you should jump into dynamic tasks. Now, especially if you've used Airflow a lot in the past, you may have heard of dynamic DAGs. And that's still a valid thing. It's sometimes a little bit confusing because the term is similar, but it refers to something very different. Dynamic DAGs refers to programmatically creating your DAG code. I said earlier you should treat your pipeline code as you would any software code. You can even generate your Airflow pipeline code based on code. So you can programmatically create it, and a lot of large companies are doing that. One popular example is the DAG factory package, where you don't even write Python anymore. You write YAML scripts, and those automatically get turned into Airflow DAGs. So that's what dynamic DAGs refers to. And what you often see with that is because programmatic creation means that you can easily create a lot of DAGs based on, for example, a configuration file, like in the DAG factory, that often the number of DAGs will change, and that you have, for example, in this case, one DAG that fetches the sunrise time, one that fetches the weather code, and one that acts on wind data. So you often see this pattern, and whenever you're thinking, well, I want to have one DAG per X, like one static DAG per X, then you should think about dynamic DAGs. But what is important is that usually those DAGs change because code changed somewhere. Sometimes that's just in a configuration file that gets fetched automatically, but there will be some base code change that leads to this changing number of DAGs. A very common question here is, well, can I use dynamic tasks in my dynamic DAGs? And the answer is yes. All right, now let's dive into the actual code. How do we do this? How do we make a dynamic task? So here, first on line 44 to line 48, you can see a regular task. We put at task on top of our function. And in this case, I just hard-coded what I'm returning on line 48. I'm returning 2 file paths. But in reality, this would be the task that makes, for example, an API call and figures out how many files are on a specific server. And what we're pretending here is that we would have a different number of file paths every single day. So maybe one day it's 10 and the next day it's 300. So we never know how many file paths we get, but we want to process each file separately in parallel. And that's what we're doing in the second task. And most of the code here is actually optional. But what you can see here is we have a task called process file on line 51, and we're calling that task on line 61. And now we have 3 components. The first component is everything that stays the same no matter which mapped task instance we're in. I call this constant, and everything that stays the same needs to go into the .partial method. So instead of just calling this Python function and giving it one input for constant, one input for file, I'm calling it with a method called .partial, and then I'm saying, okay, the constant is 42. This does not need to be named constant. This could be named anything. Usually you have a whole set of parameters that stay the same. For example, if you're interacting with a database, you're using the same database name, the same schema every day, but maybe you're acting on different tables. So the second part is the part that changes. And that part goes into the .expand method. So after .partial, I'm saying .expand. And for the file parameter in this function, I want this parameter to turn into the individual file paths that I'm giving it. So I'm giving it a list of file paths, and it will automatically create a mapped task for each element in this list. So in this case, you want to guess in the chat, if I run this code, how many mapped task instances do we get? Exactly, we get 2. We have folder file 1 and folder file 2. But if we would have a task that gets a changing number of files, we could get 400 tomorrow without needing to adapt our DAG code. It just runs everything in parallel. The third part here is optional and it's new. It's part of Airflow 2.9, and it's that you can actually add a custom map index in your UI. You will see that on the next slide what it looks like, but this is what all this code here does. So this is the optional code here. In the task, I'm saying map index template. So I'm saying the map index that I want to display should be based on a template. And I'm using a new template here called my custom map index. And then inside of the task, I can say, okay, I'm getting my current Airflow context. Do you remember I said there's something called context that is always available to your DAGs? And then I'm defining that my custom map index to be the string I processed and then my file path with the constant and then my constant. So this is what will be displayed in the UI. By default, if you do not do this, you will just get a number. Your mapped task instances will just be numbered. But a lot of times you want to quickly see, well, which one failed if you have 100. And then you can name them, and it's very easy to see at a glance, oh, this file is the one that caused the failure. All right, so this is what this looks like in the UI. So here we have a dynamically mapped task, the process file task. And as Nicholas correctly said, we have 2 dynamically mapped task instances, and they actually display this string here. We processed file 1 with the constant, we processed file 2 with the constant. If you just have 2, it's not that important to name them. If you have over 100, it starts to get very important. This is the cheat sheet. I will not read through this, but this is for you to reference. You'll get the slides after the presentation, what the different methods do, and there's also some hints at more advanced ways of doing dynamic task mapping, because sometimes you have several keyword arguments that change in between your dynamically mapped task instances, and of course that is also possible. There are full examples on how to do that in the ebook that we will share. All right, let's talk a little bit about the second advanced feature. Sometimes you want to run a DAG not based on time, but based on updates to data. The prime example is you have a data engineering team and you have a machine learning engineering team. And their workflows depend on each other. The data team prepares the training data set, the machine learning team needs that data set so their model can run. But they also don't want to work on the same DAG code because they don't want to get in each other's way. So what you can do is you can have a data set in the middle. You have the first DAG. This is the DAG from the data engineering team. I called it my ETL DAG. And this DAG contains what we call a producer task. That task, as soon as that task finishes successfully, the dataset will receive an update. Now, the task doesn't actually need to interact with the dataset. So you as the DAG author say, okay, this task, when it completes successfully, the dataset should be updated. Personally, I imagine it as little flags. So whenever that producer task completes successfully, it waves its little flag. And the word on the flag is the dataset URI. And what you can then do on the consuming side is you can have a full DAG to be scheduled not on time, but based on combinations of these flags. So you can say, okay, this DAG, I want this DAG to run whenever this specific flag is raised, and I don't care which task did that. There could be several tasks in different DAGs in your Airflow instance that all produce to the same data set, and whenever any of those tasks complete successfully, your consumer DAG runs. That's how you do this in code. It's a little simpler than dynamic task mapping. For the producer task, you just add the outlets parameter and you set that equal to a list of all of the data sets that are updated by this task. And you can see here, this task doesn't actually interact with S3 at all. It was just me that said this data set is updated. The data set is identified by its unique URI. So if you have the exact same URI in a dataset, those will be connected. Little side note, usually you use variables for this. You don't hard code it in 2 different places because it's very simple to make a typo and then it won't work anymore. But for demonstration purposes, I wanted to hard code it here so you can see the full URI. And then you have the consumer DAG, and here you just set the schedule parameter to the list of datasets that need to receive an update in order for this DAG to run. So in this case, whenever this producer task completes successfully, no matter in which DAG it is, then this DAG will run. This is what it looks like in the UI. We have a producer task. This task is inside the myETL DAG. Then we have the dataset. These datasets only start to show up in the UI if you're on Airflow 2.9 or later. But using this type of dataset scheduling works as of Airflow 2.4. And whenever it has received an update, this consumer DAG will run because it's scheduled based on this specific dataset. That's the basic dataset scheduling. But as you see in this cheat sheet, there are some advanced options. Because a lot of times, the most common feedback we got when the feature was first released in Airflow 2.4 was, but what if I want my DAG to run based on either this dataset or the other one? And as of Airflow 2.9, that is finally possible. I was very excited when this came out. You can set the schedule to a tuple of datasets, and you can say, I want this DAG to either run this one here, the first advanced bullet point, I want the DAG that has the schedule to run either when dataset A is updated or when dataset B is updated. This little pipe here stands for OR. You can also use an ampersand for an AND operator, and you can nest this, you can nest AND and OR structures as complex as you want them to be. So you could have a whole complex logic behind your dataset schedule. The other very common request was, well, I have a DAG that I want to run every day at a certain point in time, but I also want to have an extra run when data is updated. And that's possible with the dataset or time schedule. In that case, you use this class, and then you have a timetable parameter where you just use a regular timetable, for example, a cron trigger timetable. And then you have your datasets parameter where you can again provide any conditional structure of datasets. So that is one of the advanced data-driven scheduling options that you have with Airflow. And there is an example DAG that uses this type of scheduling in the repository, and an example DAG that uses this type of scheduling. For experts, there are a couple of new features that came out in Airflow 2.9. There's something called dataset alias that allows you to define a dataset if you don't know its URI yet. So you give it an alias, a name, and then you start attaching different URIs to your name. And you can also, as of Airflow 2.10, attach data to your datasets. For example, what if the dataset, if it's important how many rows you have interacted with in a database, you can attach that information to one of these dataset events, so to an update to a dataset, and then fetch that information when you are working with that dataset. That can be quite complex, but I have information on that in the ebook, and the ebook then also links out to more documentation, especially on how to interact with that extra information. All right, so we're almost at the end, and I want to leave enough time for questions. Just a couple more best practice features that I wanted to call out here. Do you have a task that takes a long time to run, that waits maybe for several hours until a file is ready or until a model has been fine-tuned? In that case, you really want to look into deferrable operators. A deferrable operator is a regular operator that will just release its worker slot when it's waiting, and a completely separate component inside of Airflow called the triggerer will run an asynchronous process that keeps waiting for that action. Usually it polls an API. So that other component is the little child in the back of the car that keeps asking, for example, your model training service, is the fine-tuning done? Is the fine-tuning done? And only when the response is yes, will the task be picked back up and will finish running. And the worker slot is released in that time. So the worker, your Airflow worker, can do other work in that time. Sometimes, depending on how you structure your pipelines, deferrable operators can really save you a lot of cost. There's a whole chapter on that in the ebook. The other thing is if you start passing data between your tasks. So in the very first DAG code that I've shown, I ended up printing information that was returned by a previous task. And maybe some of you have used Airflow a long time in the past, and maybe were thinking, hey, I was once told you should not pass data between your tasks. That used to be true, because whenever you pass data between your tasks, that needs to be saved somewhere. We need to preserve state, and by default, that is written to your Airflow metadata database. And this database, it works fine for small amounts of data, like a little fact about cats, for example. But as soon as you have larger data, whole data sets, that used to fill up very quickly and could impact performance. But now we have ways to replace that backend. So this feature is called custom XCOM backends. And what happens is every time your tasks talk, instead of saving that data in your Airflow metadata database, it will be saved somewhere else, usually some blob storage like S3, Azure Blob Storage, or GCS. And as of Airflow 2.9, it's actually very simple to set that up. It used to be a little more complex. And there's also a chapter on how to do that in the ebook. The other thing I just wanted to call out for the advanced users, you may not have heard about task run if and skip if. You can have run and skip decisions directly on a task based on elements of the context. This is new as of Airflow 2.10. There's an example DAG that shows you how to do that in the repository. And you can also reuse your task flow task by using .override. There's also an example DAG on that. All right, the recap here is shorter. Dynamic task mapping, that is the way you can create pipelines that adapt to your data at runtime. And datasets allow for data-driven schedules. Personally, I'm at the point where usually a couple of DAGs run based on time, and the whole rest of DAGs runs based on dataset updates in my environments. All right, so these are the resources that we have for you. I kept mentioning an ebook and a repository, and I see Tori already put a lot of links in the chat. You can use those links. You can also scan the QR codes here. But what we did is we wrote up a lot of information on all of this in a book that's called The Ultimate Guide to Apache Airflow DAGs. It's a little on the longer side with, I think, 130 pages, but it contains a lot more examples and explanations around all of the features that I just mentioned. There's also a repository specifically for this webinar that has example code for each of the features. And in the README of the repository, you find instructions on how to run this code locally using some of Astronomer's free tooling. And if that is fun, if you enjoy using Airflow locally, playing around with it, and you're thinking, I kind of want to try out running these pipelines in the cloud, then you can use a free Astro trial where you get $300 in credits, so you can try out our commercial product Astro. And with that, I think we have a little bit of time left for the Q&A.
Absolutely. Thank you so much, Tamara. I mean, what a ton of information. You really broke it down so well. Thank you so much. Before we dive into our questions, just reminding everyone that now is the time to get straight from the source insights and advice from Tamara. And great questions always make for a great discussion. So if you do have any questions, don't forget to share them in the Q&A. But we also understand if you need to run. And just a reminder, again, today's session has been recorded and will be emailed to you within the next 48 hours. And if we don't get to your question or your comment today, you can always connect with Tamara via the channels on screen, and they are in the chat. I know she'd be happy to chat with you after this webinar. So jumping right in so we can squeeze in a few here. First question is coming in from Damon. Are there some best practices for testing DAG code before fully committing to production?
Oh yes, that's a very, very good question. And I love that you asked it, because for a lot of people, testing is an afterthought. And then you end up with the SpongeBob meme. And yes, there are. And I can actually, this is the ebook that you get that you should see now, that you get if you download it. And there's a chapter on testing Airflow DAGs. And if I skip to this, what you keep in mind, like to basically summarize this chapter, is you have testing of the DAG code itself. Then you have CI/CD, so that the testing is automatic and the promotion to your deployment is automatic. And to not forget about data quality checks, which is almost a separate thing that you can also build into your DAGs. And within the testing, the three things, if I zoom in here a little, that you should think about is unit testing, of course. So all of your custom Python code, if you're not using an operator from the community, you should have a unit test for your custom operator for the code that you're using in @task decorated functions. Then you have DAG validation tests. Those are specific tests like, for example, have I set retries in all of my DAGs? Or have I set catch up to false? Or you can also, for example, restrict which operators people are allowed to use. So these are tests that really run on your DAGs. And then lastly, you have integration tests. And this is sometimes tricky to do because it can be expensive. But for some key processes, you may want to have a copy of your DAG running in a staging environment so you know that your changes work end to end. I hope this answers the question really quick. I want to leave time for other questions, but you will find examples for all of these in the ebook, especially the DAG validation tests. because those are sometimes a little trickier to write because you need to interact with Airflow models, but you have an example here.
Thank you. Yeah, we're right at time, but I just want to squeeze in maybe one or two more if that's okay with you, Tamara.
Yeah, definitely.
Um, Question coming in from Nicholas. Assuming we have an operator for each service that DAG interacts with, how do we create a new operator? What's the best practice for creating a new operator?
Great question. So you basically have two options. When you run into this situation, you go onto the registry. This is the registry I mentioned, and you look for an operator, and then there's just none there for your use case. And one is that you just write it ad hoc by using @task on top of a Python function. But as you said, you can write your own operators. And this is something that I ended up not putting into the book because it was already too long. But here, I will put this in the chat. This is a guide, and this walks you through how to create custom hooks and custom operators. So basically what you do, you inherit from the base operator, and then you just override different methods. And there's some optional things that you can do, but you have a very simple example here. You also have a simple example for a hook. And then down here, you have a more complex example. That's probably the worst way you can do math, but I wanted to show how you can write an operator that has different parameters here. And here you have an example hook. So a lot of times you put everything that interacts with an API into the hook, and then you call the methods of a hook inside of your Airflow function. And one of the things that I always do is I usually start with these examples. I copy paste these and then I'm starting to build it out. But if you need inspiration to write really good Airflow code, one of the things you can do is, I have the link up here. All of the Airflow code, because it's open source, you can look at the code and you can look at different operators that have already been written. So going to the providers folder. Currently there's only one here because they're in the process of migrating all of them in preparation of Airflow 3. But you can look at the different, here it's Airbyte operators, and then you can look at the code behind of all of the operators and get some inspiration on how the Airflow devs have written it. So following the basics in the guide that I linked and then getting more inspiration from the source.
Perfect. Thank you, Tamara. And the last question I have for today, again, if we didn't get to your question, please feel free to follow up after this webinar. I will also make sure Tamara has all of these questions so she can reach out to you as well. But the last question we'll take today is from James. I have a DAG that consistently fails when it runs on schedule. However, it will succeed when I trigger it manually. Are there any reasons this could be happening?
Oh, that's a good one. I had this once, and the reason was because I was using something from the context. I don't remember which parameter it was, but it was a parameter that was different when you run it manually and scheduled. I think it was based on the logical date, and it had a different number, slightly different format of the date time in the DAG run ID. That is a very specific way that it happened for me. But what you want to look at is if it runs on schedule, is the data ready that you might depend on? Maybe there is some slight delay, and when you run it manually, maybe a few minutes later, the data is there. That can be happening. You obviously want to dig into the logs of the task that failed. And you also want to double check everything that you're using from the context. Like, for example, in this case, if you're using any time-based parameters, things like the data interval start date can differ depending on something that is running on a schedule and run manually. In that case, the data interval start date, if you run it on schedule, it will be the logical date. But if you run it manually, it is sometimes the moment when you run it. And if you have SQL code or some other code that depends on the state, that can be the source of failure. But that can be a difficult one to debug. I
Thank
hope
you
that
so
helps.
much. And with that, that is all the time we have for today. I hope you all learned, I mean, half as much as I did. Before we go, I just want to encourage you to participate in the survey that will pop up in your browser after this webinar closes. We value your feedback and help to produce valuable webinars that you enjoy, just like this one. Thank you again to our sponsor, Astronomer. And Tamara, a big special thank you to you for taking the time to answer our questions and provide us with such a wonderful presentation. Thank you.
Yeah, thank you so much. And thanks so much to everyone who joined. I hope this will be helpful to you. And I hope you have a great rest of the week.
Yes, a huge thank you to all of you for joining us today.
Yeah.
Again, my name is Tara, and I hope you have a fantastic rest of your day and week. Take care.